Hello everyone, it's Peter here, Piotr Wissner. How are you doing, guys? So, there is a bit of a problem. I've got customers who are coming with inverters, and sometimes I can fix, if the MOSFETs are failing or something. Sometimes, yes, sometimes transformers are failing, high frequency transformers, and now the only problem is that various inverters have various transformers, and I can't have always the ones in stock which I need, because I don't know how many windings is on the primary, secondary. I would have to rewind it, and I don't have that much time to rewind it. I can do it one off from time to time, but I can't do it, like all the time if you have them. Now, I would like to fix them all if possible, but unfortunately at the moment I will be just piling them up as a faulty ones. Then one day we will measure those wires, and on both primary and secondary we will order those wires. We will remove the foil, the wrap. We will open, count, and I want to do it in a group of people, like more people. So I'm thinking about some event that come and help us. Yes, just come and help us unwind, write down how many turns and so on. We will group them as well, so we will see maybe they've got similar names here. Yes, if they've got similar names, we can unwind one, have that in mind. And if we can unglue it and open it, then there is a chance of fixing it. Yes, not all of them you can open, not all of them you can fix, but you can quite a few. So the next step, because that will be sometime in the future, I just don't like throwing them to the bin. Now I would like to order more of them as well, in a bulk. Yes, like the same values. So then we could create a database that this device has this specification of the transformer, that has this, yes, and I would like to maintain this database with other people who are fixing them or fixing other devices and finding faulty transformers, yes, because it's easier in a group than on my own, yes. So yes, that's my goal. So I'm creating a new playlist about inverters at the moment, and when I will have a bunch of them, I will create additional about transformers. Now in the transformers, of course, there will be talk only about the transformers, and that's it. Which devices we see with what transformers and windings, etc. Were I able to open them, or maybe they crack broken, like I was doing one here. I placed it somewhere, it doesn't matter. Not always I can just open them and without breaking them, yes. So so I can then tell the technique, and maybe somebody can comment down below how they've opened it without damaging, and that would be an add-on value. I can pin those replies or create additional video about it. About the inverters, yes. Now I would like to design a really good, a really robust inverter. It can be based on the high frequency transformers, of course, that's not a problem. I've seen as well that the Victron Energy has toroidal transformer, yes, so that's a different design. Now I need a pure sine, and I need a minimum 500 watts, but I would need as well 1000 watts. So if I could create one module, and I can add another, yes, not in the series, in parallel. And as we know, if I need 230 volts, then we're talking peak time times 2, yes. So we're talking for 60 volts, so it can kill you. So if you don't know what you're doing, don't don't do it yourself. Go to people who know what they're doing and how to act safely with it. Excuse me. I'll show you now what I bought. Okay, so orders. I've ordered for £13.76 pure sine wave inverter, 12 volts DC, up to 24 to 180 to 20. We've got 380 because we've got ×2. That's the square wave probably, or something, and then it's getting 220. I don't know. I will have it here. I'll know. Then I can create a video about it. Yes. But for now, you know, let's focus on this, that it's a DC, gives us DC and gets AC out. 12 to 24 volts supply, and you get 180 to 220. So that's it. It was just bought yesterday because it's 25th of the day of the recording. And then I bought this one as well. This one is a driver board, so that's the one. And then this one, ex.ScreenProtector. Yes. So that board is needed for to create your own one. There are a number of videos about them as well. I don't know. Yes, I don't know if that's good enough board. From what I've seen, it's capable of doing quite a few things. It has it's unipolar and bipolar modulation, 4-pin set of pure sine wave output frequency, 5 volt single power supply, 50 Hz pure sine wave of fixed frequency, of 60 Hz pure sine wave of frequency 0 to 100 Hz. I don't know why they wrote in such way, but and then pure sine wave frequency adjustable 0 to 400 frequency. I think the translation is just not the greatest. Comes with a deadband control pin for dead time, 300 nanoseconds, dead time 500 nanoseconds, then dead time microsecond, doesn't matter. External 12 MHz crystal oscillator, PWM pulse width modulator, crystal oscillator. Carrier frequency 23.4 kHz, PWM carrier frequency 23.4 kHz. I was talking rubbish. Voltage, current, real-time temperature feedback. Okay, over voltage, under voltage, over current, and overheating protection. That's what we want. Yes. Soft start mode, pin setting, the response time of 1 second. Very good, we need soft start. Serial communication to set the output voltage, frequency, and other parameters. Brilliant, brilliant, you know, brilliant. External serial LCD module, 1602 displays, the inverter, voltage, frequency, temperature, and current information. Now, I've been watching several videos about EGS002, and there are mixed reviews of this board. Okay, it's based on the EG8010. It's a digital function, very well, bring their own dead time control of pure. You understand what I'm talking. Make a research yourself, you'll understand. Just the translation on this particular one is not the greatest. What I want to say is it can do the trick. It does require additional knowledge, it does require additional hardware, yes, and safety features, because come on, we're talking to 30 volts, can electrocute us, and we're talking over 300 volts anyway over there. But I'm looking for people who would like to help me, yes, because I'm no expert whatsoever in designing electronics. Yes, I do fix it, I do fix them, I do it frequently, like daily, you know, that's what I'm doing. But I would like to speak with people who would like to and won't kill themselves, but know how to deal with electricity, high frequency, and so on, or if they do something new, they know how to at least be safe and sound. So I'm looking for those people who either are capable of or are not going to be dead because they don't know what they're doing. And I would like to test and then test those under voltage, over voltage, whatever those features are, yes, short circuit protection, everything, you know, like in the safest possible way, of course, I mean. So I would like to integrate with people like-minded who would like to create an open source inverter, pure sine inverter with all the securities. We can then create enclosures for it, yes, and so that everybody who will create it or use our design, open source design, will be able to create an enclosure for it. I would say I would go for passive and active cooling, because if using low energy, come on, you don't need active cooling. Next, I would use a sensor for that fan if fan is failing, so it should the power go down, decrease the power, yes. And then if you don't see fan spin or made a diode that fan issue, and so that all those features would be pulled in. And then once we've got this, I would like to get maybe ESP32 or something to communicate that data with a user, yes, via Wi-Fi. So that's what I would like to do. Create an open source inverter which we can build on our own, order PCBs ourselves, get components if it's possible, and we could create modular. So let's say, well, that's not, but let's say that's 500 watts just for the argument's sake. So that's 500 watts. So I would like to add parallel module, you know, and create an opportunity to connect them together, solder them together, so it's thick enough solder that it will allow, let's say, yes. And then if you've got 1000 watts and 500 watts, you cover most of the needs, let's say, yes, like for regular users. And then we can think if it's worth to do it as well in the parallel, or we need to redesign and have a PCB for, let's say, 2 kilowatts, and then we can create those 2 kilowatts as well as a parallel. So those questions I need to ask myself and speak with others. I've got only one reply from one guy. Of all the YouTube channels out there, one guy was keen enough to reply, and he said he's busy till the end of March, so in April he can help me design it. He don't know about EG002, so I want to start talks after the March. And yeah, and I would like to know your opinion as well, if you're into it, of course, I mean, and that's something which you would like to be involved, because I can't find a decent, like something which I wouldn't put an argument about, yes. I've seen quite good inverters, to be true, just several days ago, like before 20th of March, there was one video at one YouTube channel. I don't want to tell which one, just so that you can go and search, but there are popping out more frequently videos with better quality inverters. Maybe because of EG002, I'm not saying because of that, but I'm saying maybe because I see usage of this, so it has a good potential, but I need something which nobody will argue is a good one, yes. So yes, and I'm not saying it will be for everybody, I'm saying for those who want to tinker with it, yes, and are into it. That's it, guys. That's everything in this video. I've got nothing else to tell you, but for sure, yes, for sure, let's do something about it. Let's create an inverter which will be robust, safe, modular if possible, yes, so that if you've got one, you can create second one. Fixable, yes, fixable, and open source. Okay, it has to be open source so people can have an access to it and they can do whatever they want with it, tweak it, make it better, whatever. Yes. So those factors, I'm saying them from top of my head, so don't quote me, I won't remember them in a week time, but those things I will be, you know, because that's common thing I'd say. That's it, guys, that's everything. I can't think of anything else, so let's call it a day. Yeah. Thank you for watching. See you in the next video. If possible, leave us a like button. Here's likes to use, you know, like maybe a bit more. Yeah, likes. Thank you. Yeah, I know. Don't need a comment on that. But anyways, see you in the next video. Cheerio. Bye bye.